Only one copy of a static data member exists in the entire program. A constant member behaves like a static, but its value is marked as fixed and constant. The compiler knows its value, therefore it can make substitutions and avoid memory allocation for a constant member. Let's see the finer details. Static data members are accessed by the name of the class. They are members of the class, not of an object or instance of that class. Consider a class that contains a static member called count. This member is a static member, so compiler will create it only once. And next we have added an instance member called mname. This member will be created whenever an object of this class is created. It is meant to hold data for the object. You can think of it as a personal member. So we can see a sort of a contrast comparison here. A static member holds data for a class, whereas an instance member holds data for its object. Secondly, there is only one static member even if you create 20 objects of this class. But there will be 20 instance members if 20 objects of this class are created. Each object has its own personal mname. And after that, we have added a static constructor to initialize static members of this class. We have set count equal to 0. It has been done just for the sake of it so that you know that a static constructor can often be provided to initialize the static members. In this case, it was not necessary. Runtime was in any case going to set it to its default value, which is also 0. And next we add a parameterized constructor to set the value of mname and to increment the static member count. There is only one static member called count. This means that we can now keep a count of the number of objects created so far. The same count is incremented whenever an object of this class is created. I have attached the source code to the downloads of this tutorial. You can obtain it there also. And next, we have the main function, where we have created an object of the class. We can now display the value of the static member by using the name of the class myClass.count. It should print 1 because we have created one object so far and count has been incremented once in its constructor. Next, a second object is created and again the count is printed. We expect the output to be 2 now. Run the project to verify that the output is exactly as expected. This is how static members work. Let us next come to the constant keyword. Consider this class that contains a constant member called const float rate is equal to 10.0. A developer marks a data member as constant to promise that the value of this member will not change throughout his project. Numeric and string constants are the most commonly used. Values must be given immediately, like we have done constant float rate is equal to 10.0. We can add a string constant const string bank is equal to bank of xyz, and we have immediately given it a string value. The compiler knows its value when it is compiling. And lastly, we have added a function called print to display the values. A constant is accessed in the same way as a static. It is accessed by using the name of the class. So we have accessed it as myClass.rate. Now what's the whole point about the constant keyword? You must be wondering about this question right now. Notice that the compiler knows the value of a constant member at design time. So it can substitute the value wherever the identifier has been used. This means it can fold away the constants and prevent unnecessary allocation of memory. So after substitution, the compiler compiles rate of interest is equal to 10.0 instead of console.writeline rate. Hence, it doesn't have to